In this video we'll show you how we can handle multiple cavities in the wire EDM software. So I've created a simple drawing. Across the top we've got 4 cavities which will machine as individual cavities, and therefore there'll be a wire break and a wire rethread sequence required between each cavity, and across the bottom we'll turn that into one continuous path. So the thing to do is to produce a start point on each one of those cavities. So in this case what I'll do is I'll just use the intersect with midpoint split command and just create a split in that line at its midpoint. Now when I choose the NC command, I can set the datum to where I want it to be, maybe the bottom left hand corner, and use the contour to create contours of each one of those. Now when you're creating contours, the default is that it will use the automatic tracing feature. What that means is that when you put the mouse over the line, it will find the start point and find the direction, and it will automatically just create the contour. And then we can do the same thing on each one of those. So what that does is it looks at each line segment and finds another line or an arc segment which is contiguous with it, and it will automatically follow the path round any shape that it comes across. Now on the bottom ones here, if we want to construct that as one continuous contour, then we'll have to add on some connecting lines. So probably the easiest way to show you this is just to do a midpoint split on these adjacent faces, and then use the normal line option in near snap to draw a line. Press escape at the end of each one, press escape. Okay, now before I create the contour, I go to View, Preferences, Tracing, and unselect Use the Automatic Trace feature, and you'll see what happens now. So I'm just going to start off creating a contour along this bottom edge here, and I'll choose that line as the first line. So it traces round because there's no decision points until it gets to here. So now I choose this as my next segment. Now there's a decision point, it could go up here or it could go down, so I want it to go up. And again, no decision, so it goes round to the end, follows here, up, follow that one, up. So now it's got back to this decision point, so I go back along here and it goes round here, and I go back along this one and it goes round here, and I go back along this one, and then it gets round to the start point again. Okay, so that's created that as a single contour. So if we just save that drawing away, and I'll call that EDM multi. So we'll take that through into the EDM software. Okay, so we've got 5 cavities there, and the system has automatically created 5 go round commands. So if we look at this first cavity here, which was contour 0, we double click that. So we want to cut in the forward direction. If we're cutting around the inside, we'll be offsetting the wire to the right, and under the options tab we specify the pilot hole position. So this is where you would need to know where the start point is on the shape that you're machining, such that you can specify a pilot hole, and therefore you'll be able to drill the material at those locations where it's possible to cut the wire. So you notice that it's put the pilot hole on the inside of there because the contour is going round clockwise and the offset was to the right, therefore the pilot hole must be inside that. So we do the same thing on each one of those contours. select the pilot hole position at a distance away from the start point, offset to the right, options pilot hole 5mm, and so on. And then the last one here, offset to the right, options pilot hole 5mm. But one thing also to consider, when the wire is approaching and coming away from the contour, this is the lead in and lead out. So the default, if we go to this tab here, the default is just a straightforward linear movement from the pilot hole onto the material. We can specify a linear plus an arc motion, so that that's a tangential motion onto the arc and then onto the material. If you're using that, be aware, because some controllers, particularly FANUC controllers, won't allow wire compensation G41, G42 to be applied on the first move if the second move is tangential, which it would be in this case. So for those situations, we've got another option here, which is rectangular. So it produces a rectangular sort of movement going from the pilot hole 90 degrees up, then across 90 degrees, and then it puts the tangential move on. So the tangential move is the third move, not the second one. So if you come across a situation where your machine alarms out when it's applying the compensation, that's the reason why. Okay, so that's done the machining on those contours there. Now we do the same thing on this contour here. We offset the wire to the right, set the pilot hole position to be whatever you want it to be. Okay, so if we look at that in the ISO view now, so the sequence of operations is the machine starts from the datum position, moves to the first contour, stops the machine, you thread the wire, it machines around that cavity back to the pilot hole position, the machine stops, you cut the wire, it rapids across to the second cavity, you rethread the wire, machine it, back to the pilot hole, stop, you cut the wire, across to the next cavity, stop, rethread the wire, press cycle start, and then so on. Then at the last one here, it goes to the end of this cavity here, machines the whole cavity around, then stops, and then when it gets to the end of that, it goes back in rapid motion with the wire cut back to the datum position. So that's two methods of machining multiple cavities. The actual shape of them can be whatever you want, it doesn't make any difference, but that's the sequence of events.